It's been 3 years already since the last video about this project, because there was no meaningful update. But that has changed. I now have a battery, and I decided to immediately ruin it. After making a design and started working on making the battery housing, I've decided to leave it to the experts, because with every bit of new insight I gained about how battery packs are built, I learned more and more that I could not build the battery to a standard that would be somewhat safe and reliable. And I really do not want this thing to blow up between my legs or electrocute me. So I got this battery from Amorge. It's a Chinese company. It has 26 cells in series, 4 parallel, 20 amp hours battery, and with a nominal voltage at 96 volt with a max current of 200 amps. This should be enough to make the 12 to 50 kilowatt of power that I wanted when I started this project. Before I could fit the battery in the frame, I had to file off some bumps in the frame.
This bit here is flat. It's not sticking out, same as this one.
And after that was done, I noticed that the battery still did not fit, because the top lid of the battery was sticking out a little bit on the sides, and it would now lean on top of the frame, which is not ideal. I tried putting the battery in different orientations, but then the battery and the wires would stick out to the sides, meaning that I would hit the battery with my legs, and the part that sticks out would not be protected in any way if the bike were ever to fall over. I did need to cut a small part of the frame to try out a different orientation for the battery, which was something that up till now I tried to avoid. Because I wanted to make this bike street legal, which I thought meant that if I did not make any changes to the frame, only the drivetrain would have to be checked and approved. But I later found out that according to the law in the Netherlands, converting the bike from petrol to electric would be treated as a completely new bike. And that meant that the frame has to be checked and approved anyway. But since this project is now taking so long and I just want it to be done, I'm going to not make it street legal. So I no longer care about keeping the whole frame intact and do what must be done to get this thing in running order. When I finally made my mind up about the orientation of the battery, I cut off the sides and cleaned up the edges of the top cover of the new battery to make it fit inside the frame. After cutting the sides off the top cover of the battery, I added some silicone kit to close the gaps. In hindsight, I should have added some tape to make the edge of the silicone kit look better, but the gaps are closed and you probably won't be able to easily see it anyway once the battery sits inside the frame. So I call that good enough. When that was done, I started working on the battery holder. It's made from 3mm steel plate and part of my eyesight, because I did not check if the welding helmet that I put on was working. It did not have batteries in it. On top of that, I almost managed to set my glove on fire.
I burned my glove.
After that, it was time to figure out where to put the main battery switch and the electronics speed controller. For the main battery switch, I chose to put it where the fuel tank and the cap used to be, right in front of the seat, and for the electronic speed controller, I want to place it under the seat where you can't touch the thing, so no one has to go through the shocking experience of touching the battery terminals. For both the main switch and ESC, I have designed and 3D printed brackets to mount them in, and then bolt them to the frame using already existing mounting points on the frame. Of course, on the first iteration of the electronic speed controller's mount, I made the big mistake of switching the width and the length that I measured around, which made it no longer fit in the frame. I've gone through multiple iterations of each mount, and every one of them took somewhere between 4 to 9 hours to print on my old CR6 Special Edition 3D printer, but with each iteration there were some improvements. Currently everything is printed in PLA and as a temporary test piece solution, because it's easy to print and cheap, but the final version should be done in a different, slightly stronger material like PETG or ASA. But we all know that temporary solutions tend to become permanent ones, so these are the final versions, until they break. It's finally time to connect everything and test the complete drivetrain with the battery. When I turn the battery switch on, the controller threw a fault code for high input voltage, because the battery right now sits at 99 volts, but the motor controller has limits set to 96 volts.
Motor controller is on.
The first options that came to my mind to fix this issue were: option 1, find a way to get some energy out of the battery to lower the voltage from 99 volts to 96 volts. Option 2, override the limit set on the motor controller and set it to 99 volts. I went for the third option. After filling up with some ice cream, I went for option 2. I found out there is a firmware version for the controller that has no limits. So I proceeded to install that firmware version, increase the voltage limit, and hope that no magic smoke would escape. After all that, I went through the field-oriented control setup in the VESC tools, and then the motor did not work. I was getting overcurrent errors and overvoltage errors, even though it looked like the current would not go past 1 amp. And I had changed the max input voltage. All the motor was doing was shake a little bit and make some high-pitched coil whine noises. It turned out that I had filled in the wrong motor specs. The motor poles was set to 6 when it should have been 10, because the motor has 5 pole pairs. After going through the FOC setup again with the correct motor settings, it finally worked and the motor now spins. Now the throttle mapping needs to be tuned, because the throttle response is really bad. You need to go more than half throttle for the motor to begin spinning, and after that the motor power ramps up really aggressively. But we have to keep in mind that right now the wheel is off the ground and there's no load on the drivetrain. Maybe with some load on the wheel the throttle response will be better. But in order to test that, I need a good front wheel first. After all that, I hope I could say the project is done, good enough, and this is the last video about it. But it's not, because there are still a few things that need to be done before you can say the bike is put together good enough to ride. Things that need to be done are putting on a new front tire and replacing the bearing on the front rim, replace broken rear shock absorber, new handlebar grips, tucking away all the wires in the frame, and adding a DC-DC converter that can convert 80 to 110 volts down to 12 volts, so all the original electrical stuff on the bike can be reused. Hopefully it won't take another 3 years before the next video is done. You can help with that by liking the video and subscribing. I have also set up a Patreon page for people who want to give a little bit of extra support. This is also where I will be uploading some of the schemas and models used in projects. That way you can take a look close at how things are done and help a little bit with speeding up the progress of these projects.